So our last two inference procedures, still using our Spirit Air data so that we can predict the cost based on distance. Our state plan do conclude we're going to conduct a linear regression t-test to assess the true slope beta, which is the only kind of test we're using for slope. So if there were no relationship between the two, so no linear association, we would say that beta is equal to 0. Here we think that the farther away we go, the more expensive it's going to be, so we would have a positive association. So we can still have greater than, less than, or not equal to, but it will always be a value of 0. It's not going to be given to you. You don't have to write it symbolically and in words. It's easy enough just to use the symbols. The liner is the acronym for the conditions. That whole thing represents the work for the conditions. And again, any of the plots that you have and are referring to, you have to have jotted down somewhere. So for linear, I drew a scatter plot in number 1, and that does show moderately a linear relationship. Following just in order, I for independent, it's reasonable that the cost to one city is independent of another, but these are all from Pittsburgh. And so we looked at the 10% that we likely have over 150 flight paths when other cities happen to be used. Normals and newer conditions. So a normal probability plot, an NPP of the residuals, is linear, which indicates normality. So when normal probability plots are linear, that is an indication of normality. And remember, that would have been found by going to second stat plot and looking at the last option and calling up that residual list, which again is under second stat. That's under my list of lists. E is for equal variance. And so the residual plot in number 10 shows not just a random scatter, but an even scatter above and below that axis there. So kind of top and bottom of the plot. And then random was failed. I didn't randomly pick the flights. I picked kind of interesting ones and just to get a variety of places. So that's my state and plan. It takes all of that just to get through state and plan. So identifying the test, writing my hypotheses, and then working through those conditions. So my test statistic down at the bottom corner, B is the statistic, remember, and that's the slope I get from my least squares regression line. And then beta is my parameter that I'm using to estimate the true slope. And I have that set equal to 0. So it's really B divided by the standard error of B. So if we were looking at computer output, it would be in that second row. And the first number divided by the second gives me the third. On the calculator, if I go to my favorite place, StatCalc, or StatTest, sorry, there is a LinReg t-test. And there's a confidence in it as well. So if I go to my t-test, I have a pretty large value for t, 5.782, which, remember, the t distribution is a bell curve and is approaching the normal curve. So if my z-scores, I was used to about 3 standard deviations away, captured 99.7%, then my t-test statistic being 5.782 standard deviations away, that's pretty far out there. So my p-value actually showed up in scientific notation, so I would just call it essentially 0. It's so small. And then degrees of freedom, remember, is n minus 2. And so I had 15 cities I was interested in. And so 15 points, 15x comma y's minus 2 would be row 13 if I were looking that up in the chart, and it would just be off the chart. So again, the best I could say is that it's pretty small. So we have very strong evidence to reject H sub O. That's really at any alpha level, any significance level. If no linear association exists between distance and cost, we would almost never, so that's my essentially 0, see a positive association like ours. So again, the hypothesis test and the confidence interval, if we had started with that one, it's really the conditions that almost seemingly get a bit out of control. There's an awful lot involved, and it requires that you have these visuals. And so if they weren't given to you in the problem with computer output for you to get to the do and conclude steps, then it is an awful lot of work, and it is a matter of being able to correctly manipulate your calculator. The confidence interval is going to be way easier to work through because we don't have to restate all of our conditions. So a 95% T confidence interval, remember we're always estimating the parameter, so we're estimating the true slope. So to identify what we're doing, the procedure I just basically restated what was asked. It's the same conditions as what is above because we don't have computer output to see what the standard error is, and you're not responsible for that formula. I just use a ln/reg t interval back under stat test and came up with this 0.05. So again, that would be like about 5 cents to just under 12 cents. And so my confidence interval interpretation is that we are 95% confident the true slope of the regression line for cost versus distance is between $0.05367 per mile and $0.117 per mile. So the same formatting that we have used throughout the semester. Same thing with the test conclusion, same format that we have used, just a few adjustments now to revisit bivariate data and an awful lot of work on my condition.